Okay, thanks for everybody coming to join the talk, Solving Tech Debt by Decoupling Apps from Architecture using tao.js. A little bit about me. I've been professionally developing software for over 20 years, so I have 20 years of tech debt experience. Just over a year ago, I joined Bluebeam Inc. as a software architect. Bluebeam makes software for the construction industry used by architects, engineers, and contractors for the design, bid, and build phases of construction projects. You can find me on GitHub at Udymos and in js.la Slack as Hoffer. The inspiration for my GitHub avatar is my son, Eric. One of my early motivations for this topic came from a quote. I was recently out of college and wanted to share my love of design patterns with the rest of my team, my new team. So I proposed it to my boss. And what I didn't know then that I do know now is he's largely right. My journey into tech debt and trying to avoid it started before I finished college. I was working solo on a project at creditprovider.com in 2000 to create a service for submitting auto loan applications to different lenders where each had a different XML payload. Of course, I used XSLT, but how would I design the server and interface to manage it? I came up with 4 different architectural designs for my server, and I didn't have the knowledge to decide which was better than the other. Many Google searches always landed me at the same place, the Gang of 4 Design Patterns book. So I picked it up and read it cover to cover. And being so impacted by the knowledge I found, I went a little crazy with patterns books and started consuming any book about patterns that I could find, some of which aided me in creating tech debt while others helped me to avoid it. So I thought this talk was about tech debt. Good question. I have a few of my own stories worth sharing for how I got here. One source of tech debt is when it happens in your data model. Because I had to build a survey tool at Countrywide called ePace that could handle anyone that could be considered a customer, I used the data model resource book to design a meta model type data model for a survey application I was building for any kind of customer, a loan customer. The data model, the meta model here was using this parties and party types where a party could represent any person, any department, any organization, and there was a recursive relationship to describe hierarchies. In addition, the surveys would have to link to a survey questions, and to get to the responses, I'd have to go through there and get the question text, and then finally one more join to get the options, to get the actual values of the answers they provided. While it worked really well for putting the data in, the sole purpose of this tool was to report on customer surveys. And not only were my queries crazy complex with dynamic join operations, for the most basic of data fetches, it was ridiculously slow. This is when I learned the difference between OLTP and OLAP databases the hard way. Another example of tech debt is one that actually happened upon me by 2 different developers on 2 different products in the same company. One of them just walked out 2 days before a deadline to convert one product over to AngularJS, and he wasn't seen from again. This one I've seen more times than I'd like, the God object or singleton that becomes a dumping ground for everything, and it seems to just get easier to put new things in there the more and more it is used. Talk about a slippery slope. And we've all experienced that one-off project we're going to do for our favorite customer. Do we just get it done quickly, or should we think about the architecture for it? Never mind, just get it done and make them happy. But we already know how this story ends up. The salespeople saw it and started showing it to prospective customers, and then we have a jumbled mess. So how do we solve this? It's actually quite simple. You're going to kick yourself for not doing it sooner. Decouple all the things. Okay, seems right conceptually. But how is it going to be different? The solution starts with one of those books I showed earlier, a requirements pattern by Patricia Ferdinandi. It's fairly obscure, so much so I could not find a digital copy. So I had to take a picture of this figure from my book showing her a three-dimensional view of gathering requirements to ensure you've captured every aspect. This inspired me. As my team was faced with designing the new version from scratch, they struggled with how to get started and whether they were being exhaustive in their design approach, which led me to give them a framework for defining application context in 3 dimensions, focused from the user's perspective: the what, the operation, the orientation at the time. Answering a few key questions: what does the user see, and what is the app doing when? For our media management system, the terms were focused around content, users, and creation. The actions were the usual viewing, creating, editing, etc. The orientations consisted of a portal for consumers and admin plus tracking and reporting. This leads to specific application contexts to frame our questions. Taken from this view, an app is a series of transitions from state to state or context to context, sometimes holding multiple contexts at once, as well as handling side effects. We know conceptually how to decouple things by using a reactive and message-driven approach. We can now treat our application contexts as events, messages, or signals on a network where the transitions flow as messages through that network. We can embed this signal network in our client app, as well as our backend service, and so on. With other apps and services, we can connect those to each other by any means we want and with a larger signal network. We can use the same mechanisms across all of our apps and services for sharing AppCons as signals. We have now decoupled all the things, and most importantly, decoupled our apps from our architecture. But let me explain exactly how. There are 4 basic aspects of our software: what an application represents, how it does its job, where it executes, and when it does what it's designed to do. Unfortunately, when working between application and architecture layers, we commingle these 4 aspects into kind of a mess. Let's define our layers explicitly using these 4 aspects of software. The application layer is the realm of collaboration between product and engineering, deciding on what and when. The architecture layer focuses on how and where of execution. We can refine this further for each layer, providing us a clean separation between the 2. And when we get further into the details, we map it to our signals and signal network. Finally, giving us a way to organize these 4 aspects into our 2 layers so that they're represented along orthogonal lines that allow changes to happen along one line without affecting the other. The project I've been working on as a solution for this is tao.js. It allows us to decouple all the things using signals and signal networks in a way that works with the proven and experimental technologies we all love, plus take advantage of new technologies by not getting locked in on any framework choices. tao.js has a meta language for defining signals that ends up in the code. It provides the interaction primitives to determine when to react to signals. And it implements the signal networks. A trigram literally means a sequence of 3 adjacent letters or symbols. We use a trigram with the 3 letters of TAO as a mnemonic for our message format. There are 3 interaction primitives we use to attach our handlers to respond to signals that serve all of our use cases. And tao.js provides for the implementations of signal networks to connect our interactions. Additionally, our signal networks implement signal chaining, which means if the result of a handler of a signal is itself a signal, it'll feed that back into the signal network for us. We can translate the details of our layers back to tao.js. Similar to event-based systems, where a trigram is an event we can subscribe to, like using a button's on-click. An application context is an actual event that happens like when the user actually clicks on the button. Our handler on the signal network is similar to the on-click button handler in that we attach it to the button and it is called when the button is clicked. We attach our handlers to the signal network on trigrams, and it is called when an application context is signaled into the network. For our example, we'll use an example application called Conduit, which is a medium-like blog platform. The goal of realworld.io was to have something that goes beyond a to-do sample app to simulate something more like the apps we all build. When we build our applications using tao.js, we'll go through a few steps, and I'll illustrate them here using our Conduit example app. First, we define our terms. And not to forget some of the first-class relationships, like when a user favorites an article or follows another profile. By going beyond standard CRUD operations, we can define more granular actions that allow for more flexibility to subscribe to these events, more ways to flexibly define where a handler might execute. Next, we define our orientations. In this case, we have a logged in and a logged out anonymous orientations. And finally, we'll define some trigram paths, which are signal chains that implement our desired functionality. We can use Markdown to document the trigrams we work with, terms, actions, common action chains used to build the protocols and orientations. We can also document our protocols in Markdown, which make it easy to translate our use cases to our code. Setting signals using tau, we first import tau, which is the basic signal network, and we can also import an explicit app context. We simply use the set CTX function to set a context dynamically. A context will have a term, an action, and an orientation. We can also create an explicit app context to set using a special method called setAppCTX. So this is how handlers work. Once we set our appCTX in a React application, we can use a render handler as a component that will render based on listening for specific trigrams. Oops. Yeah. And then the wrapped component actually has no need for knowing what tao.js is. And we pass it in the onSubmit, which when clicked will, or when used, will set the context for us. Later, we have an inline handler on our network that will add the user, calling the backend API for us. Here's an example of a handler, that same handler working on the back end. We have an inline handler for when the user is added. It'll create the object in the database, save it, and then respond with a signal chain that the user was stored, which then prompts another chain that to enter the user and send it back. Async handlers kick off our side effects, like fetching data from the API. So here, when we enter a home, we want to find all the articles. Or if we enter the home for a logged in user, we want to find the articles for that user. We also want to kick off finding all the tags to populate the UI. Intercept handlers allow us to change the flow based on conditions. In here, we're going to check if they have a token and redirect the flow towards a logged in view. We can also use wildcards. And this is an example of using a wildcard to ensure that our API agent is set properly with either no token or the token from the user. We can use an intercept handler to validate inputs before it makes it to a handler that's going to actually add the user. Or we can use a completely full wildcard for things like logging, so we can log every app context and signal that comes through. We also have, for React, we have data handler components that allow us to react to app contexts for just their data and pass it down to child components. So we name it tabs. It's reacting on article and article tag. And the handler tells it how to treat the data and store it. And in a child render handler, we provide a context that says use the tabs data, and it'll come in our functional React component handler. There's already plenty of resources. The website for the project is tao.js.org. This is the GitHub repo. There are several packages: the core package, utils, React, Socket.io, and a router. I'd like to be back up to 100% test coverage. And there's also a Gitter IM chat that is pretty dead right now, but I'm hoping more people will like to join. If you've been looking for an open source project to contribute to, there are lots of opportunities with tao.js, as there is a lot to do, and I'm the only one working on it right now. Most importantly, I would love to get feedback if anybody wants to try it out. And I also want to give a big thank you to js.la and the organizers for providing me this opportunity, as well as the js.org handling DNS for my project and so many others.